So we want both the tangent and the normal line to this function at this point. So first we have to find the derivative. So this is what I got for the derivative of this one. So whenever you take the derivative of x's, it's just your regular derivative. But when you go the derivative of y's, do the regular power rule, but then you multiply by y prime. And I did that for these guys. This is what I got. Why don't we get y prime alone? So y prime has been isolated. And now what you want to do is you want to take your point and take the x and the y and plug them in for the x's and y's here in your derivative. So this number here, this 4 square root 2, that's the slope. Now I have a point, so why don't we build point slope? So we have point slope, y minus y1 equals m times x minus x1, but I think they wanted standard form, so let's rewrite this equation into standard form. So to recap this, I used the point and I plugged in the point into the derivative to get my slope. Once I had my slope, I went point slope to get point slope down there, and then from point slope, we went to slope intercept, and then from slope intercept, we went to standard and we finished there. Now this, by the way, this is just for the tangent. They also want the normal. So you should know that the tangent and the normal lines are perpendicular. What that means for us is we do the exact same thing, except that at this point here, instead of 4 square root 2 as our slope, we're going to use a different slope. So you see, instead of using this slope of 4 square root 2, I go perpendicular, which means you reciprocate it and you switch its sign. So proceeding from here, that's going to be your slope there in red, and you still have the same point. So go point slope and then follow the same steps as before.